sound is. How's the sound? Okay, that's not too bad. Where's the clock? Let's check the clock on. That's weird. Hey guys, how are we going today? Where are we joining us today from? Just getting a few things started. Hey Infinitum, hey Jennifer. We'll wait for a couple of minutes guys, and then we're going to get straight into this question. I've had a bit of a couple of long evenings for the last 2 days at school. Just want to get this question out, and then maybe get some shut-eye finally. Rutherford, nice. Finn, nice. That's a while away. Hawke's Bay, nice. Welcome, William. Yeah, every time I think I have to finally do it. Like I think I'm gonna get a map, and every time someone puts, I wonder if I can actually do that. Like share a map, and people can just pin like where you guys come from, and then it'd be quite cool to kind of see at the end of the day where everybody's coming from. But anyway, what are we gonna do? So we're gonna work through question 1 today, guys, from 2021 differentiation paper. So the way this works is that I'm going to do a double. So basically I'm going to go through the exam, but I'm also going to be recording it for people that want to watch it later. So, you know, it's going to be the live stream will replay, but also people can watch that exam worked answers when I'll compile it later when I've got, when I get a bit more time, yeah. But other than that, so today we'll go through question 1, and if we have time, we can start doing question 2. But really, I think after 9 o'clock, I'm probably going to crash. Dog is quiet at the moment. We've had a cat war happening in the backyard. Yeah, so the dog hasn't been sleeping much and kind of keeping me up. So anyway, that's enough life story. Let's get on to today's work. All right. So what I'll do is, as always, guys, I'm going to give you guys some time to kind of have a go at these questions. So we'll go through like question 1 to E. I'll give you guys maybe like a couple of minutes just to have a go by yourself. And once I start recording, I'll shift away from the chat screen so I can just kind of focus on the question. And then I'll pause the recording while I'll come back to the chat and try and answer any questions that's popping up. One thing that'll be handy for you guys to have with this is have your calculus formula sheet close by. I will be kind of going back and forth between screens for that. I'm gonna see if I can try and set it up. I know I always struggle to kind of set it up. Let me see if I can try and set it up. Okay, have a go at this question, and then I'll try and set the formula sheet up first for you guys. Add source, desktop capture, calculus, level 3 calculus 2016. There we go. Oh, nice. There we go. It does work. If only I had figured this out like a few years ago, it would have been nice. It's all right. Never too late. Okay, now see that does kind of disappear a little bit off the side there. Let's kind of see if we can leave it here. Is it still going to do that? No, that's fine. Cool. So question 1, we're going to try and kind of get it out of the way at the moment. I'll start recording. I think this is going to be a bit tricky. I'm trying to do too many things at the same time. Let's just get rid of that. Don't really want that. Let's record. Okay, so with question 1a, what we've got here is your straightforward achieved question. The first thing kind of people forget to see that is that this particular differentiation question that we have is we actually have to use the product rule. And the reason we've got to use the product rule is because we've actually got two separate functions here, right? So with that in mind, I'm going to see if I can switch over. No, I can't switch through that. Where is it? Yeah, let's try this one here. There we go. So it is going to be in your, what do you call it, the formula sheet if you do forget it. That's when you have like two functions multiplied by each other and then you're trying to differentiate it. So what I'm going to be doing is kind of treat it just like that. I might actually just go u is equal to e to the power of 3x, and then v is equal to sine 2 of x. So I'm going to differentiate u, which means it's going to be write everything as is, so e to the power of 3x, and multiplied by the differentiation of the power. So in this case, that's going to be 3. As for v dash, differentiation of sine is cos, so we're going to write down cos 2x, and of course we've got to multiply by the differentiation of whatever's inside the bracket. All right, now remember that in differentiation you guys don't need to actually simplify your answers fully, so you can actually just write your answer just as is. So I kind of have a little shortcut for this, is that I kind of go if y is equal to u times v. I mean, you don't need to do this, you can go straight into differentiation, that f dash g kind of thing if you want to, or u dash v, it doesn't really matter. So I just write down u dash is equal to u dash v plus u multiplied by v dash. So all I'm really doing here is just substituting all those things there. So I've got u dash is equal to 3e 3x multiplied by v, which is sine of 2x, plus u, which equals to e to the power of 3x multiplied by v dash, which is 2 cos 2x. So if you guys have a look at the answer, pretty much, you know, they don't like factorize it or simplify it, they just write it exactly as it is. And yeah, so just doing that without any simplification is actually going to get you guys an achieved. And I think the important thing is to recognize that it's actually a product rule, or sometimes they do quotient rule and chain rule. So keep that in mind. All right, how are we going in the chat here? Any kind of questions, or are happy with that? Let's go on to question number 1b. Easy. Yep. Nice infinitum. Yep. Okay, so let's and again, guys, look, like this is really important, right? Like for you guys that are doing you know, depending on how many exam papers you're doing, like if you're doing 3 externals, you've got to manage your time, right? So sometimes you got to go, well, do I need to waste my time in this achieved question, or am I really confident with that merit question, therefore I can just go straight to the merit question? So one of the strategies I recommend is reading the exam question, like even before you start write anything. Just read all the exam questions, all 3 papers, so you kind of in your head you start strategizing what's the best way to approach this, so you can actually get the maximum amount of what do you call it, marks that you can get, which then allows you to get a higher grade. All right, so anyway, this question here, look, I gotta be honest, like this question used to be a merit question for a long time, but slowly they kind of I think they kind of figured out that people just kind of learn that, get like 6 points, and then differentiate a function in another one, and then they get an achieved straight away for differentiation, which is why I think they've actually changed. Again, this is my thought. I think this is why they changed it into an achieved question. But anyway, let's kind of have a crack at this. So what I might do is, look, this question, there's not really much to do. I'm going to give you guys a minute to kind of have a look at it and just you know, just write down what you think those 3 answers are, and then I'll go through it fairly quickly. All right, so 8:10, so I'll go through the answer at 8:11, and if you feel like to put the answers up there, yep, put it in the comment section. That's all good. right, guys, just another half a minute and then I'll go through the answers. All right, so with question 2, as I said to you guys before, these questions used to be like a merit question, but yeah, like I said, they've kind of reduced the number of questions they ask and converted it into an achieved. So let's have a look at these questions here, and I'll kind of walk you guys through it. So the first thing is that in question B1, part 1, I guess, they're actually asking when is the gradient 0. So with gradient being 0, we're literally looking for flat lines. Where are all the flat lines? So that's what gradient equals to 0 is. So we can see that this part here is all flat all the way just before 2. And we also have one extra part right there where that, the curve is actually changing directions. So there is going to be another point where the gradient is actually 0. Now, sometimes people think that sharp corners are also when the gradient is 0, and that's actually incorrect, because with sharp corners, what's happening is that before that point, the gradient is like, geez, I'm trying to look at the camera and do this, but you can kind of see it, right? It's like one is negative, one is positive. I guess this is positive if I'm looking at the camera from this way. Yeah, so this is positive and this is negative. Yeah, going down. Anyway. The problem is that you've actually got a gradient going from negative to positive, and they're like two different numbers. So that's why we can't actually say the gradient is 0 at the point. So what we're going to be doing here is, so our first zone that we're looking at is that straight line that's highlighted green. So that's going to be x is less than 2. And we're going to put a little comma to say that also when x is equal to 4. So these are the 2 points when the gradient is actually 0. The next one is concave upwards. Now, sometimes people go, oh man, I can't remember, is that the U shape or the N shape? Give you guys a super little hint here, and just if you forget it, I always forget it, right? But the thing is, like concave upwards, I kind of just look at that U and I go, oh, okay, so if that's a U, that's a up. So where's everything that looks like a U? And you can kind of see that everything that looks like a U is in that zone right there that's colored in yellow. All right, now one other thing that we also have to be mindful of is that we've got a sharp point and we've also got this weird black point and a filled point, right? So that means it's concave upwards, so the way we write it, it's between 3 and 6, and it's important that you actually write it like this, right? We can't actually put equals to 6 or equals to 3, because at 6 we don't actually know what's happening, and at 3 we also don't know what's happening, so we can't really make that decision and say that, oh yep, it's actually concave up at 3, because there's a filled hole and then there's like a connecting, like a empty kind of hole later on. So because of that, we can't actually confirm that it's actually upwards at 3 and 6. So that's going to be our answer for number 2. And finally, for part 2, it says, what is the lim of as x tends to 7? So what that means is that we want to know what's the y value as the graph heads closer to 7. All right, and it's kind of, if you have a look at the graph itself, so it's kind of like coming close to this here, and it's all coming towards this circular point there. And because it's both of like the limits actually, as it's getting closer, it's getting to that point, we can kind of say that the limit is actually equal to not 4 but 3. So we're going to put that as 3 as our answer for part 2 there. So basically, I know I kind of went overboard. I didn't need that long to explain it, but I just thought I'd kind of go through some of the explanations to get that. Now, for this particular question, you actually need to get 2 out of 3 correct to get an achieved. And yes, how you write the answers do matter. So you do need to get some practice on writing those limits mainly, because these questions pretty much work on those understanding the greater than and equals to sign. So make sure you guys are like getting comfortable with it. I think I do have one whole video dedicated to it. I think it was maybe in 2017, 18 tutorials for differentiation. If you guys have a look, there is literally one whole session that goes through all of these types of questions. All right, how are you guys doing in the chat? Oh, epic, Chris. Appreciate it, man. Thank you so much. You know, it makes a difference. Maybe I do need to get some stuff out, but no, appreciate it, buddy. Thank you for that lovely thing. All right, so let me know, guys, if you guys got any question with question B. Otherwise, we'll go to a merit question, because I love, like, I'm going to be honest, like, you know, with differentiation, I love spending time in merit and excellence questions, because you know, they just pop, they come real quickly, those merit questions, and then you can easily get a few merits and excellence. Like, I would say it's actually a lot easier to get merits in these exams than to get achieved. Well, you know, you do the merit questions, 3 of them get you 15. Tom, yeah, I keep thinking about it, but it's like, man, I've just, yeah, I only recently even put on super chat now. So, oh, are you not in high school, Chris? What are you up to, man? Would love to hear your story. Hang on, I'm just gonna put the next question up while I have a chat with you, mate. So here's our next little question, guys. Have a go at this, and like I said, recognize the question, what you're using, and see if you can have a crack at it. What I'll do is I'll go through this question at about 8:20, because I don't think you're going to need more than 2.5, 3 minutes for it. Have a go, and I'll go through it at 8:20. Let me see if I can write that down. Chris, which year are you up to now? Like, which engineering are you doing? And you in Auckland? Where did you how did you find this? Sherry should ask. I think I would say it depends, Sherry. Like, I know for a fact that some guys have like gone, look, I want to get excellence in the paper, so I'm just going to try the excellence questions. But really, it's all about strategy, right? Like, I always say this: if you're spending more than a minute or two on achieved questions, you really shouldn't be like wasting time on it. And sometimes these achieved questions can take a bit of time. So like, I know like the last achieved question was like very quick, right? I mean, if you know the limits and things like that, you just go bang bang bang. That's like 30 seconds, you're done with that question. But if you get like sometimes you get achieved questions where they ask you for equation of a tangent, and you like find the gradient, and then you got to find the y value, and then you're finding the equation. Sometimes it can take like quite a bit of time, and I go, well, am I going to be wasting like 3 to 4 minutes on this achieved question, or am I going to spend that extra 1 or 2 minutes on a merit question to get that M5? Because, you know, getting two achieved questions gets you 3 points, whereas getting a merit question gets you 5 points. So that's why I always say, like, you know, try and aim for that merit question, because you make a minor mistake in a merit, you can still count for an achieved. But if you make a mistake in the achieved question, you get, you know, what, an N2? That doesn't really help you in the long run. So entirely depends on what you're aiming for, Sherry, like, and how you actually strategize. But I always say this, you know, with any of these papers, you got to try and aim for merit or excellence, because even if you kind of like make minor mistakes, you can still come back and always do those achieved questions. And we'll talk a little bit more towards the exam time, like maybe towards your mocks, that give you guys some tips on how to manage exams. So yeah, we'll kind of get to that. All right, guys, so it is 8:20. I'm going to have a go at this. Do you guys need a bit more time to work on it, or let me know what you want to do in the chat, and flexible today? Yeah, that's so true, infinitum, and I think that's why I say like start from merit. At least you know that you know, sometimes you get like a couple of merit questions, like easy merit questions where you can get like 6 points. And then, because really, if you think about it, like, you know, to get an excellence, you need around the 20-21 mark, which means in some exam papers, you can actually get one excellence question and the remaining in merits, and you're going to get an excellence, right? Because think about it, you get one excellence is worth 8 points. You got 6 and 6 for the 2 merit questions, and then your total comes up to 20. And if they have a cut score at 20 for excellence, there's your excellence. So yeah, it is. And the thing is, what we don't know is what the cut score is for that particular year. And that's the annoying thing, because you don't know if it's a 21 or a 20 or a 19. And then it kind of like, so I always say you want to try and aim for like at least 2 excellence, or at least part way through an excellence to get like 7 points kind of thing. I remember a year when I taught, I think I had a kid that was so arrogant, and he said, I'm going to do all the excellence questions, and he spent so much time on the excellence proof question, he couldn't get it right, and in the end he didn't do the second one correctly and ended up getting just like I think he got one excellence question correct where he got 8 points, and then I gave him like a couple of points for the achieved part of it, because he didn't even attempt, couldn't complete the merit component of the excellence question. So he ended up getting like, I think it was, if I remember correctly, he got like 12 points, which means he got like achieved, which kind of sucked for him. But in the real exam though, he did get an excellence. Anyway, let's go through this question here, guys. So what do we have for question C here is, once again, we've got to recognize that we've actually got a product rule here. And all they're asking is find the x coordinates of any stationary point. So all we got to do is differentiate, put it equal to 0, and then solve for x. So that's all we're doing. So we're going to go kind of with the whole u dash v. So I'm going to write down u is equal to 2x plus 3, which means u dash is equal to 2. Then we've got v is equal to e of x squared, which means v dash is equal to, I'm going to write down ex squared, and of course multiply by the differentiation of x squared, which equals to 2x. Once that's the case, I can write down that y dash is equal to u dash v plus u v dash. So we're going to get 2 times e of x squared plus, what do we got? U is equal to 2x plus 3 multiplied by v dash, which happens to be 2x ex squared. So once that's done, we can kind of see that ex squared is actually a common factor. Well, 2ex squared. So what I'm going to do is I'm going to take that out. But before, let's take the 2ex squared out. 1 plus 2x plus 3, and I'm just still going to have that x that's actually left over. So all I've done here is remember that this is my common factor. So 2ex squared, 2ex squared is my common factor. So that's why I've actually taken out 2ex squared as a common factor. All right. Now, next thing is I've got two kind of things that's happening here. So I've got 2ex squared multiplied by 1 plus, I'm going to expand the brackets here, which is 2x squared plus 3x. 3x. Yep, 2x squared plus 3x is what I've got here as my bracket. So this is all y dash. This is what my gradient function is. And I believe you will get an achieved for this question when you get up to this stage right here. All right, because that's the differentiation of the function here. Now, we know that on stationary points, the gradient is actually equal to 0. So we can kind of say that y dash is equal to 0 for stationary points. I mean, you don't need to write this, but I kind of have a habit of just writing it down. So just so that people kind of know what's happening as well. So because of that, I'm going to put down 0 is equal to 2ex squared multiplied by 2x squared plus 3x plus 1. Now, the first thing that we need to know is that e of x never can be equal to 0. So remember, this is kind of like this thing where you go where these two brackets, we've got two brackets that multiplying to equal 0, which means you've got 2ex squared is equal to 0, or 2x squared plus 3x plus 1 equals to 0. Now, with the 2ex squared equals to 0, this has no solutions because it's not possible. So we're going to almost kind of like ignore it. All right, we'll forget about it. So all we got to then do is just solve this little quadratic. Now, I know for a fact that you guys have been probably doing this in MCAT, like, you know, different, like using a quadratic formula, whatever. But these are the times when, you know, if you can use the graphics calculator to kind of get your solutions out real quickly to save time, then you do it. So we're going to go into polynomial, degree 2, and just punch in those numbers. So we got those. Hang on, where are we at? Yeah, so putting it in the graphics calculator and getting those two values, we've actually got x is equal to negative 0.5, and we also have x equals to negative 1. So when you get these two answers here, this is going to get you an answer, a grade of merit. Now, really important, right? Like sometimes people can actually get to these two answers straight away using the graphics calculator, which is why in the schedule they actually have a written statement that says, like, you got to give correct solution with correct derivative. All right, and remember, this is like at level 3. They're not looking for your skill in solving a quadratic, so you don't need to do it the long way. Just put it straight in the graphics calculator, get your answers out. Now, if you don't have a graphics calculator, I'm going to say then, yeah, you probably, I'm hoping that you're comfortable with factorizing into two brackets and putting it together, solving it. But yeah, other than that, that is what we're looking for this particular question. So guys, on the chats, if you have any kind of queries on this, just give me a yell out. Otherwise, what we'll do is we'll actually go to the next question. Yeah, so Tom, you could have done that as well. 2x squared. Oh yeah, I see what you did. Yeah, that could work as well, man. What I might do is I might just put the next question up while I try and answer Maxwell's question here. If nobody else have any questions on C, I'm happy to put up question D. Yeah, let's put question D here, right? Seems fairly quiet. All right, so if you guys want to have a go at question D, and I'll try and answer Max's question here. So what we'll do is I'm going to give you guys, this one is a little bit trickier, so I might give you guys about 3.5 minutes. All right, so Ant-Man and Maxwell, both of your questions. It depends, Maxwell, what you're doing, right? So if you're doing 3 externals, and I guess it depends on what you need. Like, for example, if you're doing engineering, I believe Auckland University Engineering, you got to have passed all 3 externals, and I can't remember this, and please don't quote me on this. I don't know what the entry requirements for AUT engineering is, whether it's all 3 or whether it's one of them. So really, Maxwell, it depends on what you need for your university entrance. What are you trying to do? If you're trying to do engineering, I would say all 3 is probably important. But if you're doing like for university entrance, then I would probably go with complex. I would probably say complex numbers. Oh, is it now? Thanks, Tom. Did not know that. So, wow. Okay, no, I did not know that. There you go, Maxwell. So if you're doing engineering at UOA, according to Tom, it's been changed to 2 only required. So again, mate, like, look, you got to figure out what actually works for you. Like, I mean, I wish I could tell you guys which paper is easy, but the truth is, what I've found is that every year one of them seems to be a bit tricky. I haven't done, I mean, I did complex numbers earlier this year, the 2021 paper, and it was too bad. I mean, I thought it was I thought it was pretty straightforward. Differentiation so far has been pretty straightforward. I mean, like later on in the year we'll do integration. If you're doing like anything with comp sci and stuff like that, like complex numbers is really like it's quite handy to have, because it's just, you know, like I'm trying to how do I put this? You know, again, people might say completely different things, but like I see it as like, you know, if you're working with variables, you're working with programming language, so you're understanding how to separate variables based on whether it's real, imaginary. My thinking is, and again, this is my limited knowledge in comp sci thinking, probably say complex numbers is quite useful for you. But I've also heard, who was it, University of Auckland or one of the universities came out and said that if you can pass differentiation at level 3, that's really good, as it's like a good benchmark for the rest of the papers. So, you know, different people, different requirements and kind of suggestions. So Ant-Man, how much time do you have to work on all 3 papers? If you're doing 3 papers, it's going to be 3 hours. If you do only 1 paper, you still have a 3-hour time slot for it. So because the way the exams work is that you're going to have like, you know, like say for example, they say, right, on the 19th of November, I don't know, whenever calculus exam is, they'll go, well, you're there, you're going to get 3 hours to do, even if it's whether it's 1, 2 papers or 3 papers, you're going to get 3 hours to do it. Yeah, I need to freshen up my requirements for universities. I haven't actually. I guess it's a bit hard because I teach you know, I teach year 8 maths at the moment, year 8 and year 9 maths. So yeah, my biggest concern is like YASTL and things like that. So I guess that's why I've kind of been drifting away from it. But anyway, let's get through this question here, guys. Bit of a little bit longer question. Yeah, let me just put this up here. Okay, so am I recording this? Just move this around first. Okay, so question 1D, what we've got is a parametric equation. So we've got x and we've got y. And funnily enough, the way they've done it for y is that it's actually a product rule in there. So we've got this kind of like extra bit of thing actually happening there as well. Okay, so with that in mind, we are trying to figure out, find the gradient of the tangent to the curve at the point 10. All right, so what we're looking for is we're actually looking for f dash of 10. So our first thing that we want to be doing here is we've actually got to work out what the gradient function is. All right, so and remember, we are working with parametric equations, and I'm just going to show you guys quickly the formula sheet if I can find it. Oh, there we go. Where is it? Okay, so it is under the in the formula sheet under parametric function. So basically, when you have like x of t and y of t, you kind of work them out separately, find what their gradients is, and then put it together to work out what dy dx is, or in this case that we said f dash. So with that in mind, our first thing is that we've got x is equal to t squared plus 3t. Now also remember, like this is just another notation, right? So what we're really asked to find is what is dy of dx when x is equal to 10. All right, so that's that kind of way of thinking about it. So I've got x equals to this, so dx dt, I need to differentiate it, which is going to be 2t plus 3. So that is dx dt. Now I've got to work out what y is. So y is equal to t squared ln of 2t minus 3. And remember this thing that I did earlier in this question, right? There's a lot of product rule for like one question. I've got to be honest. So u is equal to t squared, v is equal to ln of 2t minus 3, which means u dash is equal to 2t, v dash is equal to 1 over 2t minus 3 multiplied by the differentiation of whatever's inside here, which happens to be 2. All right, so I haven't even got to dy dx, because I need to first work out what dy dt is. So dy dt is equal to u dash v multiplied by u v dash. So u dash is equal to 2t multiplied by v, which happens to be ln of 2t minus 3. That should not be multiplied, that should be plus u is equal to t squared multiplied by, what do we got, 2t squared multiplied by 2 over 2t minus 3. All right, so once that's all done, I'm just going to kind of write it in a bit more closer or neater. So I've got 2t ln of 2t minus 3 plus 2t squared over 2t minus 3. Now, as you guys can see, that it's starting to get a bit ugly here, but that's all right. We now have to work out what dy dx is. All right, so dy dx is equal to dy dt multiplied by dt over dx. So here's a couple of hints for you guys. Like, what you can do is, I mean, I could write that whole thing down, right? Like the whole dy dx. I mean, I don't have a choice. I've got 2t ln of 2t minus 3 plus 2t squared over 2t minus 3. And this whole thing is actually multiplied by 1 over 2t plus 3. See, and the reason it's 1 over 2t plus 3 is because we're doing dt dx. And we initially found out that dx dt is 2t plus 3. So when we do dt dx, we are flipping it over, and that's why we get this 1 over 2t plus 3. Now what I'm going to do is I'm actually going to kind of, I want to get rid of this. Right? Oh, no, I'll leave it here. Find the gradient at 10, 0. So what are we going to do next? So we're actually finding the gradient, right? So at 10, 0, what do we got? T squared plus 3t equals to 10. Give me 1 second, guys. I think I got drifted away with this question. $10.0. What am I missing here? Right. So I guess at the moment what I got to try and figure out is I got to actually figure out what t is, right? Because I've been given x and y, but I need to actually figure out what t is to actually work out what the gradient is. So what I've got here, give us a second. So here's what I know. My x value is equal to 10. But in this gradient function, all I have is t. So I actually need to figure out what is t when x equals to 10. So what I can then do is I also know that x is equal to t squared plus 3t. Because of that, I can actually say 10 is equal to t squared plus 3t. And with that in mind, I can rearrange this and I'm going to get t squared plus 3t minus 10 equals to 0. So I've got a nice little quadratic. I'm going to work out the quadratic, and when I work out the quadratic, I'm going to get t plus 5 and t minus 2. And so when I do t plus 5 is equal to 0 or t minus 2 equals to 0, I'm going to get t is equal to negative 5, and I'm going to get t is equal to positive 2. However, there is an important part that we need to remember. It actually says for t that's actually greater than 1.5. And because t is greater than 1.5, so we're going to say that since t is bigger than 3 over 2, t is equal to positive 2. And because it's t is equal to positive 2, now all I got to do is I got to go into dy dx. And I've got this extremely ugly looking equation, which is 2t ln of 2t minus 3 plus 2t squared over 2t minus 3 multiplied by 1 over 2t plus 3. And all I got to do is I've actually got to put down all those all the t's as 2. All right, so because we said that t is equal to 2, we now have to substitute everything that has a t in there with the 2. So we're going to get 2 times 2 ln of 2 times 2 is 4, 4 minus 3 is 1, plus 2 times 2 squared over 2 times 2 is 4, 4 minus 3 is 1, multiplied by 1 over 2 times 2 is 4 plus 3 is 7. So now ln of 1 is equal to 0, so I don't have to worry about that. 2 times 2 squared is 8, so I've got this times 1 over 7, and what I'm going to get is 8 over 7 right there as my answer. Yeah, like I said, like, look, it was a bit of an annoying question because, you know, again, I kind of had to pause and think a little bit about where I'm going to get that, where I'm going to go with this question with the t. And yeah, anyway, pretty much this is going to get you, oh, wow, no way. This is an excellence question, guys. Like, I did not realize that. Check this out. I thought it would be a merit question, but clearly not. This is an excellence question. So T1, there we go. Correct solution with correct dy dx actually gets you a T1. I think that would mean that T1 gets you E7. So it gets you 7 points if you actually get 8 over 7. That's pretty pretty impressive there. Solve to find T is -5 or -2 gets you a merit. That's pretty impressive. So that means we're looking at somewhere here for a merit. Dy dt correct gets you an achieved. So that's just this thing right there. I didn't realize this was an excellence question, but guess what? It is an excellence question. And what's 7 points? So if you got 8 over 7, that's actually going to get you an excellence. I'll come back to chat now to answer some questions. Oh, wow. Oh, Vista, thank you so much, mate. Jeez. Appreciate it, dude. Like, that's legend. What are you doing this year? Are you doing university, or are you at level 1, 2? I mean, not level 1, obviously. 2 or 3? Let me know, man. Thank you again. Appreciate it, mate. I think I need to keep track of these people to kind of like do like a shout out or something like that at the end here. Nice, Vista. How are you finding engineering, man? Like, I mean, what? This is in second semester at the moment? Are you doing it at University of Auckland or AUT? Because Nippy's got a question there. Any thoughts on where to go to AUT or UOA? So many mixed messages that I've got. Like, some people love AUT, some people love UOA. I don't know. I did engineering first year in Auckland University, and I dropped out after that. Oh, Canterbury, nice. Very nice, very nice. All right, guys, so if you don't have any questions with question 1D, what we'll do is we'll actually jump on to question 1E. Otherwise, I'll just leave this question up for like maybe another half a minute just to see if anybody's got any questions. If not, I will move on to question E, and I'll put the question E up so you guys can have a go, and then we'll actually go through this question, and I think we'll be on time for a 9 p.m. finish. Why did I drop out? Oh, mate, that's a legendary story, that one. I dropped out because I failed miserably in university. Like, I think, like, let me put it this way. In 2000, I did university. Hang on, let me just clear something up here. There we go. So in 2000, I did engineering. Failed my first semester. I failed like 3 papers. What did I pass in my first semester? yeah, out of the 4 papers, I failed 2 papers in my first semester. Second semester, I failed 3 out of the 4 in engineering. Then I went to maths. I switched my degree to maths. I failed the next 2000. I think the next 1, 2, 3, 4 next 4 years. I had like the worst university career ever. I failed like so many times. Finally, in 2005, I was like, look, better clean up my act and actually get a degree. So yeah, it took like 6 years to do like a 3-year degree, man. Like I failed so many times. So, but yeah, just didn't want to drop out and didn't want to quit. Just wanted to kind of keep going, persevering. There you go. Here I am. Long story, Nippy. Long story. What I'll do is I'll give you guys like a few minutes to kind of go at this question, and then we'll kind of go through it. Because I love these types of questions. They seem to kind of come through. Uh, thanks, Sherry. Look, I'll be honest. Like, I was kind of doing this on my own as well, because like my I was just saying, I was like doing some crazy amount of working, like because I started living here by myself when I was 18. Um, 18 January 20, yeah, it was 18. I was 18 years old when I started living by myself here, because my parents moved to Australia when I was 18. Had a bit of I think I had like $400 in my bank account and two suitcases. That's all I had, and pretty much worked from there, man. Still working, still kind of doing the hard yards, still working, but at the same time just enjoying it. Yeah, Nippy, you'll be surprised at some of the stories I have, man. Like I have some crazy stories. I think about it every now and then. I'm like, you know what? I should actually just sit down and just have a chat with. Because I used to do this with my year 13s. Back when I was teaching year 13s, every year at the end of the very last calculus class that I have, I actually don't teach them any calculus at all. We all go out and maybe find like sometimes we could just go out and find a quiet space out in the field or something like that and just sit down, and I literally just tell them these kind of like these stories that I went through, because I wish someone had kind of told me that at 18, like, you know, things are gonna be hard, but you pull through, and you lose some friends, you gain new friends, and yeah, it's really cool. And I kind of miss that, right? Because it's like trying to do that with year eights. It's like they don't really care. Year eights and year nines don't really care, but I think at year 13, people do care. So you kind of go, tell them stories. So maybe for you guys at the end of the year, I'll tell you guys some stories. It'll always be a fun little chill out session, as I call it. Like, well, I'm here 3 nights a week, but one night for calculus. Sorry, Maxwell. But guys, honestly, in my class, I don't really teach. I just kind of like put the videos up and just have conversation with kids. Because I think that's what year 13s need, right? It's not about like, because if they're in the right state of mind and if they're like ready to do stuff, you guys will do it. I mean, you guys right now have made a choice to be here. I mean, you don't have to be here right now, but you've actually said, this guy's running a tutorial. I'm going to listen in and see if I can learn something. So that's a choice you made. And I think as you get older, you kind of start to learn about, those choices that you make, how that kind of helps you along the way. So yeah, that's what I tend to do. I kind of like do a lot of talking than teaching. All right, so let's get through this last question, and then we'll call it a night, so you guys can actually go get some rest. What have we got? Volume of a cylinder. Do they actually give you guys volume of a cylinder in the Oh, they do too. All right, so here we go. Look, like sometimes I mean I know some of these guys. I mean they're like incredible teachers, man. Like they just, I think it's just learning how to understand the language they speak. Like and that's the beauty of maths, right? Like I actually did one entire day where I spoke in my home language and I taught maths, not in English, but I actually taught it as because it was like International Day. And I said to the kids, like today, I said to them, tomorrow I'm going to come dressed in my traditional costume and I'm going to speak my language the whole day. And I'm going to teach you calculus the whole day in my own language. And interestingly enough, kids actually learned quite a bit that day. And the reason is because they were like, I don't understand what this guy is saying, but I'm going to try and make an effort to understand what he's doing. And so they were watching how I was manipulating the numbers and moving things. And it was really such an interesting little social experiment that I did. Yeah. Now, I mean, like, yeah, I like having conversation with kids, man. It's good fun. But anyway, look, let's get through this question here, so we can kind of call it. But so what do we have for this question? Look, with these types of excellence questions that they pop up, there's always like, find the maximum volume of this shape inside of this shape, or this cone inside of a sphere, and they just come up with these consistent shapes, right? Like sometimes they have a cube and a sphere inside a cube, or a cuboid inside a sphere. So all it is that you just got to try to kind of like break the question down, all right? So in this question, like I've seen this shape, and the first thing I look at is I'm going to go right to the bottom there. It says prove that the maximum volume of the cylinder is pi m cubed, right? So all I'm looking at is I just need to worry about the volume of cylinder. So what I'm going to do is I'm going to head down to the, what do we got? We've got our trusty formula sheet, and I'm going to go in there and have a look at the cylinder right there. Okay, so volume is equal to pi r squared h. That's all I actually need for right now. So I'm going to write that down first here in the corner somewhere. So volume is equal to pi r squared h. And majority of the time with these types of questions, what happens is you've got to get rid of one of the variables. So we've got to have all the variables with the same letter, because remember that when the radius changes, the height changes here, and because of that, what we've got to do is we've got to make sure we don't actually have different variables in these things, in the equation itself. Because what we're going to do is we're going to differentiate dv dr or dh, whichever one it is, and we're going to have to try and figure out, put it equal to 0, double differentiate, and we're done. Okay. Now the issue here is we've got to figure out a way to get rid of this h. And the way we're going to get rid of this h is you almost take this three-dimensional shape and we're going to make it into a two-dimensional shape. So what do I mean by that? I am going to create a little x and y axis graph here, and I'm going to draw my cone in a red line like this. Okay, now with that in mind, I know that this is 1.5 right here. It's positive 1.5, and then this is going to be negative 1.5, but don't really care about it. I just care about the positive 1.5. The next thing, I also know that it has a height of 3, so this value right here is going to be positive 3. So far, so good. Now, I need to know what's happening with the cylinder's height with respect to radius, all right? So if I think about the cylinder, my cylinder is going to look like a rectangle, because when I look at it from 2D, it's going to look like a rectangle. So it's going to look like this right here. So I hope that you guys can kind of see that connection, what I've done there with the three-dimensional shape to two-dimensional shape. So if I say the radius is from here to here for the cylinder, I actually need to figure out what the height is. Now the way I'm going to work out what the height is I've actually got to get the equation of this line right here. Because along that line, wherever the radius is, it's going to give me whatever the height is, but I need the equation of that pink line there. Because think about it like this. Let's say I have another cylinder that's a little bit taller and skinnier. It's going to look like that. And so where our heights actually change, but the height is actually dependent on that pink line. Now, if you look at the pink line itself, it has a gradient of, what is it, rise over run. So we're going to have that as a straight line there. So we're going to put y equals mx plus c. We know that it cuts at 3. So we're going to put c is equal to 3. And we have rise over run. So the rise, in this case, it's dropping, which means it's going to be minus 3. And the run is 1.5. So we can actually rewrite this as y is equal to negative 3x plus, no, I've got something wrong here, hang on, negative 2x plus 3. All right, basically this is the equation of that pink line right there. But of course we've got that in radius, so we just need to change that to, instead of y, what we have is h. Instead of x, what we have is r. So we're going to get h is equal to 3 minus 2r. And I think this is probably the most trickiest part of this question, because once you get this part, and majority of these excellence questions with these shape inside a shape question, all you got to do is you got to get that first, how do you get rid of that one of that variable? Because once you do that, the rest of the question is pretty much a walk in the park. Because let's have a look here, because that was the hard part, right? So we know that volume is equal to pi r squared h. We can go volume is equal to pi r squared h is equal to 3 minus 2r. And then we're just going to expand this bracket, differentiate. So we're going to get 3 pi r squared minus 2 pi r cubed. So this is our volume function. When we differentiate this, we are going to get v dash, which is equal to 6 pi r minus 6 pi r squared. All right, so all I've done is I've just differentiated v right there. Now, we know that at a maximum, v dash is equal to 0. So we're going to put 0 is equal to 6 pi r minus 6 pi r squared. So 0 is equal to, we're going to factorize it. So 6 pi r is a common factor. 1 minus r equals to 0. Sorry, 1 minus r. So because of that, we can actually say 6 pi r is equal to 0, or 1 minus r is equal to 0. Now, if 6 pi r equals to 0, we can say that r is equal to 0. As for 1 minus r is equal to 0, we can say that r is equal to 1. Okay, so what we've just discovered is the maximum volume happens when the radius is equal to 1. So our next step is to actually go prove that the volume is actually equal to pi. Now we know that volume is equal to 3 pi r squared minus 2 pi r cubed. And because r is equal to 1, we can say 3 pi 1 squared minus 2 pi 1 cubed. What we're going to end up with is 3 pi take away 2 pi, which equals to pi. So as you can see, we have just proven that the volume is pi meter cubed. But here's the thing. There is one more thing. It actually says prove that the maximum volume is. And I think this is what people actually sometimes miss, and it's really important. When sometimes they ask you for like maximum or minimum, they will actually write a little statement in italics and say like, you don't need to show this is a maximum or a minimum. In this case, they're not actually saying that, which means you do need to double differentiate and actually prove that this is a maximum. All right, even though we know that, you know, the minimum in this case is going to be 0. Like if you think about it, the minimum volume in this is going to be 0. So we've got to do the double differentiation. So what we're going to do is we're going to take v dash, which is 6 pi r minus 6 pi r squared. We're going to differentiate it twice, which means we're going to get 6 pi minus 12 pi r. And at this point, we've got to substitute r is equal to 1 again. So we're going to put v dash for r is equal to 1, which is equal to 6 pi minus 12 pi times 1. And what we're going to get is 6 pi take away 12 pi, which equals to negative 6 pi. And at this point, we can say negative 6 pi is less than 0. Therefore, V is maximum. So you can also put it like V dash double dash is less than 0. I should actually do that here. Sorry, give me 1 second. So I should have done it like this. I should have gone V double dash is less than 0 as negative 6 pi less than 0. Therefore, V is maximum. So grades wise, surprisingly, this question has actually got 2 T's. Let me show you guys what I mean by. So in the previous question, we actually got a T1. In this question, you got a T1 and a T2, which basically means that, let's say you didn't get anything correct in this previous question, but in this question, you actually do the full question with the proving that it's a maximum volume with V double dash, you're going to get a T2, which is actually worth 8 points. All right. So if we were to go back to the working out here, grades wise, as I said, you're going to get like an excellence for so both grades. So 8 points, full 8 points if you get right to the end. If you do not prove it's a maximum, then you actually get 7 points. So if you get up to here, you're going to get like, I guess an E7, and then this is an E8. Finds R is equal to 1 is going to get you a merit right there. And achieved is DVDR. So DVDR is right there, which is going to get you an achieved. So yeah, that's basically question 1 there, guys. How are we doing for questions here? And how was that question? So yeah, like I said, I mean, like, I think that question took me, you know, while I was explaining, it took me about 9 minutes. But I think if you're doing it, you're kind of expecting to kind of do that in about 7 to 8 minutes. But look, Tom, just let me know which part was challenging, and then we kind of can talk it through, man. So where did you guys get stuck at? Yep, I can actually do another quick example with that rise over run, Ant-Man. So what you could do is in your calculator, go straight into stat mode, and you can actually put those 2 points in. So you can actually go 0 and, oh no, I go like this, 0 and 3. And then you're going to put down 1.5 and 0. And if you click on graph 1, what did I do? Oh yeah, I didn't put that value, did I? 1.5. I don't know what happened. There we go. So when I click on X, right, it's actually going to give me the equation right there, which is negative 2x plus 3. Yeah, so Tom, I think that was the part, right? So if you ever get stuck with a question like this, try and see if you can convert it from a 3-dimensional shape to a 2D shape. All right. So notice how I actually converted that like perspective. Really, it's just changing the perspective of how you look at that question. Because the moment you put that into like a 2-dimensional perspective, you can kind of see like X and Y axis, or you see like R and H. And pretty much, sometimes they do similar triangles. Like I think most of the questions before has been like similar triangles or shapes where it's like double that of double the radius of the height or something like that. Finding out. Maxwell, how do you get V dash equals to 0 and V double dash is, sorry, V double dash should be less than 0? Because when we do double differentiation, remember that when it's negative, when you double differentiate and substitute the value, if like the x value, and if you get the double differentiation value as a negative, it's going to be a maximum, and if it's positive, it's a minimum. We know that V dash is equal to 0 for if you want to find a maximum or minimum, because remember, that's the turning point. So maximum volume is going to equal 0, or minimum volume is also going to equal to 0. Jasvinder, why is it -3 over 1.5? Because I'm actually doing rise over run. So if you look at this particular graph here, that's at 3, that's at 1.5. So I'm going down. So I'm going down, which is equal to -3, and I'm going right, which is plus 1.5. So that's where the rise over run comes from. Yep, nice. Thanks, Sherry. Got it, Max. Yeah, less than 0 is negative is max, positive is minimum. No, Tom, no, you're right. It is concavity, and you can also use this for volume questions and area questions as well. So I think in level 2 calculus they sometimes don't. Some teachers teach second derivative. I kind of been teaching that with the kids. I just tell them like, look, just do the second derivative because it's something that you guys will use at level 3 anyway. So you might as well kind of learn that at the moment. Yeah, like I said, Tom, like earlier in this question, like you do need to read the question. So sometimes they'll actually say you don't need to prove that this is a maximum or a minimum. I'm just going to see if I can try and find a question like that. Must use calculus. Okay, so in this very, like if you look at this question here, this is the same paper but question 3E. Right at the bottom, they actually say that out loud. So if they don't say that, I would almost say do the second derivative test to prove it. If they say this, then actually say to yourself, right, I'm not going to actually do it with the second derivative test. So yeah, that was pretty much from the, that's question 3E in this exact paper. Like right at the end, they're like, you don't need to show that it's a maximum value. Cool, guys. Look, that's pretty much it for us today. And I guess just thank you, Vistas 777 and Chris Kwan for your just coffee today. I think that's what I would say. But apart from that, the rest of you guys, thank you so much for joining today. Look, I think we're doing Thursday nights for level 3 at the moment. And if anything changes, I've just readjusted my time slots at the moment. So I'm doing Sunday level 1, level 2 on Tuesday, and level 3 on Thursday. So I'll probably go through question 2 next week with you guys for differentiation. And yeah, we'll take our time just kind of working through it so you guys can ask questions along the way as well. But at the same time, if you guys have any like other questions in the meantime that you're like, oh, I kind of need this answered, just drop an email and I'll see if I can try and get to it. Yes, John, you can email it. I'm happy to make. Also, John, I think one thing that does help is like, I mean, if you do have the answers, just flick them to you, because like if I'm going to make a video, what I don't want to do is like work out the wrong answer and then get people on the wrong track. Would really appreciate it if you do have the answer. I don't care about the working, just the answer really, because then it helps me knowing that I'm putting the correct answer out there, because you guys know it's so easy to get one little minus symbol wrong somewhere and the whole video is gone bung. I think there's quite a few engineers here, Sherry. Like they seem to come back even after they finish level 3 calc, just to kind of just hang around. And yeah, I really appreciate that, because sometimes it's nice to kind of see and talk to people that are doing engineering right now. For you guys, it's just like an informal way to kind of ask questions to them as well. Hey, welcome back, Revish. How you going, man? What are you up to now? Oh, very nice, John. You legend, Max. I appreciate it, man. Thank you so much. Civil engineering, look at you go, buddy. Man, I remember the time you actually sat through all of those tutorials in 2020 and when we did Mathdemic. Was it like every night you used to come to the level 2 and level 3 tutorials? Have a good night, Nippy. Yeah, I remember it's like every time it's like, here's a question from Revish again. Yeah, the mock exams, I think are done by Syncos and Cohere, and those papers are like, they push you, man. Like John, I would actually say if you get your hands on those questions, practice those questions because they really prep you for the end of your exams because they're like some really good, hard, tricky questions in there, those papers. What's the time? What do we got? 2011. Nah, sleep time. Sleep time. See, this is what happens when your kid gets your tablet. They start putting random stuff in the back. Yeah, they are. They are different different ones, eh? Because it's just like I remember doing some of those questions back in the day. Like I'd be like, what are these people trying to ask here? Because it's just like the questions don't make sense. And then you look at the answer schedule and you're like, it still doesn't make sense. And I remember like doing some of the old papers. It just pain, man. Like pain to understand the questions, and then after you understand the questions, like for me, I'm trying to figure out is like, okay, so how do I explain these kind of questions to you guys? And it ends up being like you kind of go, oh, okay, so I understand how they're doing it. Okay, now I've got to try and understand it and figure out a way to explain to you guys so that I'm not confusing people. Yeah, so it's I think you can ask your teachers, guys, like your teachers should have all the old papers, so they tend to like, if you just ask them, like they usually can share some of them. So like I used to have this massive folder of like old exam papers that I collected, and I kind of just went, right, you know what, like if my students when they did year 13, I'd literally share them this folder like with like I think almost like 5 exam papers in each for every year. So we'd have the NCEA papers, then we'd have SynCos, then we'd have Cohere papers. Sometimes we got papers from like NZAMT. We got practice papers from like a couple of other companies released some papers. So I put it all together and just, yeah. And that's the best way to practice for these exams, guys. Like just go through the old papers and literally just hammer them out. I wish, John, I really wish I did. Let me just, sorry, give me 1 second. I just want to try something out here. Does this actually work? What does this do? Just kind of messing around with a couple of things here. Oh wow, look at that. Oh, so I can actually do this. This is interesting. I can't see anything. Can't see what's actually written here, can I? Let's try something here. Hang on. So the side just pops up. That's actually easier. No, John, I actually don't have access to that folder because I was in my old school email address and it disappeared. I can't read this thing, man. This thing is like so tiny. Can you hang on? I'm just trying to figure this out. What do we got? Size, text size. There we go. That's much better. I can actually read that. Yeah, it would be good, John. It's always kind of find out what happens. Like, I just ask them. Like, most teachers have it saved up somewhere. Like, they do have it, and like, but I would say like just go through those practice papers, and you're pretty much good to go, eh? Oh, that was good fun. Like, but guys, I'm gonna take off. Need to get some shut eye, and I will catch you guys next Thursday. Have a good one, and in the meantime, if you do have any questions, yeah, just send it to the email. I think I'll try and get onto it on maybe Monday or Wednesday night if I get some time to do some work. Otherwise, I'll see you guys on Thursday. Take care, guys. Till the next time. See you later.